All right, welcome back. Next up is 1.3, the idea of finding the inverse function. So an inverse function is a function where the x and y elements are switched from the original function. So they're given this example here, AB, and the other one contains BA. We're just switching the x and y values. If that's true, then we have what's called an inverse relation. Inverse function is when it's also a one-to-one situation where the original function would obviously have to pass the vertical line test to be a function, but then it also passes what's called the horizontal line test for the inverse to also be a function. So the idea of finding your inverse function, you're going to rewrite the function notation f of x or g of x, whatever it is, as y. You're then going to rewrite that y as an x and rewrite the x in the problem as a y, and you're going to solve for the new y. Once you've solved for it, you're going to rewrite it back into its proper inverse notation, where if we're dealing with f of x, f with negative 1 of x is the inverse notation for f of x. If we were dealing with g or h or any of the other types of names for a function, it would just be that same letter with that negative 1 of x part. So we're going to take a look at three main types of inverse functions, a radical type, a power type, and then a rational type. The other types of functions we can deal with for inverse functions we'll get into more as we explore later units, the idea of exponentials and logs, their inverses, trig function, their inverses, and stuff like that. So again, first thing we're doing is rewriting f of x as y, and then rewriting the y as x, and the other x as a y. If you want, because that first step is pretty straightforward and kind of almost trivial, if you want to just rewrite the function as x and then the x as y as the very first step and not do this y equal part to begin with, that's perfectly fine. And now we're doing everything we can to isolate y. So we're recognizing we're going to get rid of a cube root, a negative 2, and a plus 3. Well, I can't get rid of the negative 2 yet because it's trapped inside the radical. I can't get rid of the radical yet because there's still something outside the radical that we have to move. So that's what we're going to do first. We're going to subtract the 3 over first. Once everything that's not inside the radical has been removed, we can now get rid of the radical by cubing both sides, the opposite of the radical. Please, 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 please do not FOIL out these expressions. Leave them as just simply x minus 3 cubed or to the 4th or 5th or whatever the exponent happens to be. Don't actually FOIL it out. It's an unnecessary waste of time. And then finally, to get y by itself, we just have to add the 2 over. Now that y is all by itself, our final answer is the inverse notation, so it's at f negative 1 of x, and then x minus 3 cubed plus 2. So again, all we're doing is just whatever is on this side with the new y, we're just moving them all over and just calling your basic solving equation rules, moving things away that are outside of the radical first, and then get rid of the radical, and then get rid of the stuff on the inside. Same rules apply when we deal with powers. So again, if I rewrite the function as just x, kind of combine steps 1 and 2 together, rewrite x as y. To get rid of the power of 3, I have to, similar to the radical problem, I have to get rid of everything that's not being raised to the power of 3. So I have to get rid of the positive 2 and the negative 3 before I can get rid of the exponent, and then get rid of the 4 on the inside because it's kind of trapped. So we subtract the 2 over. And then we divide both sides by the negative 3, so it's x minus 2 over negative 3. If that negative 3 could kind of go into either the pieces, we could write a fraction reduced or anything like that, then we would go ahead and do that. Obviously, it doesn't go with x or 2, so we're kind of stuck there. We go ahead and then take the cube root of both sides. So we get the cube root of x minus 2 over negative 3 equals y plus 4. So then we subtract the 4 over, and then we get y by itself. Y would equal the cube roots of x minus 2 over negative 3 minus 4. Now, technically, there's a couple things we could still do further with this. I'm just going to write what the inverse answer is down here, leaving some room for doing some extra steps. I'm fine with this right here being our answer for our particular class. Not looking for you to go any further than that. Where you can go further is recognizing that this cube root expression is really the cube root of x minus 2 over the cube root of negative 3. And you're not allowed to have a radical in the denominator. It's not considered proper form. I do find it to be a little bit different when there's variables involved there, because then what's considered proper? Well, I mean, if x was, for example, an 8, a minus 2 is 6, divided by negative 3 is now negative 2. There's no more fraction, so leaving a radical in the denominator doesn't really bother me when it's part of a radical expression with the variable x. But if you do need to rationalize it, We just simply then go, okay, we multiply by the cube roots of 9, the top and bottom. Because by doing that, we'd get the cube root of 9x minus 18 up top. The bottom would just be a negative 3 now. Because negative 3 times 9 is negative 27, which is a perfect cube. Negatives don't matter for odd roots, so we just pull it out, and then cube root of 27 is 3. That's what you would do if you needed to rationalize. So if your teacher required that, you just separate the radical into two separate pieces, multiply the top and bottom by the perfect number to make it a perfect cube. 3 needs to be a 27, so we multiply by 9, whatever the number happens to be. But again, since it's part of a expression with a variable of x, I don't find it necessary to actually do that. So for our class, you guys don't have to worry about that. And when not in my class watching this, you might have to. All right, so that's pretty much the same premise as the radical expression. So the next type is, the last type really, just going to be a rational function. So we have fx equals 7 over x plus 5 plus 3. So again, I'll rewrite the function as x, rewrite the x as y. Like with the radicals and like with the powers, I can't deal with the fraction until things that are not part of the fraction are gone. I mean, I got to subtract the 3 over. Now from here, what I'm going to do is I'm going to recognize that x minus 3 is really over 1, and I'm going to cross multiply the expressions. I'm going to say y plus 5 times x minus 3 equals 7. And while you may be tempted to FOIL it out, I would caution against that, because we're trying to solve for y. And if we FOIL, you're going to create two y expressions there, a y times the x and the y times the negative 3, neither of which is good because they don't combine. So I'm going to leave them separate because all I got to do now is just divide over the x minus 3. And now the y is no longer part of the denominator of a fraction, and it's no longer part of a product there. Where I can just simply subtract the 5 over. And now I have my notation. I can write as my inverse. F negative 1 of x is 7 over x minus 3 minus 5. Okay. Depending upon your comfort level with proportions, because that's what this essentially was created, we had x minus 3 equals 7 over y plus 5. What's really happening here is when you cross multiply, you can just switch objects on the diagonal, the same diagonal they're on, because then you yield the exact same product. So that's all we essentially did. If you notice, if you look at what we have right here versus what we have right here, all we did was just simply switch locations with the x minus 3 and y plus 5. And that's perfectly fine. You can do that every single time you're trying to cross multiply. So it's a very useful tool when trying to solve out for a variable that's in the denominator and you want to get it out of that spot. All right, so that's it for inverse functions. Again, there's other types of inverse, and then depending on different complexity levels for those basic ones we just talked about, but that's the idea. You're trying to isolate the new variable that you just rewrote, the x's and y. So next up, we're going to be using our calculators to analyze different types of graphs, looking for minimums and maximums, intercepts, both x and y, as well as look for intersection points between two curves. So make sure when you're watching that video, you're taking out your calculator and following along exactly, otherwise the video is not going to do too much for you. All right, so I'll see you everyone next time for that video.